Hello, let's learn how to solve for x in x to the power of 3 equal to 5 to the power of 3. We are asked to solve for x. Don't forget to give this video a thumbs up, share it with friends and colleagues, and remember to subscribe to my channel for more simplified math content. Now, given this kind of expression, many will just decide to say, let 3 cancel out 3, and then x will be equal to 5. You might be right, but then maths is not as easy as this. If it is, then many will be solving it. But then if we do it this other way, we can have a better solution to this expression. How about if we make it this way, x to the power of 3 subtract 5 to the power of 3 from both sides, then the right hand side will be equal to 0. Now, if you look at this expression thoroughly, you come to find out that the left-hand side forms what we call an algebraic expression. Now, do you recall that algebraic expression? Now, look at this. If you have a to the power of 3 subtracting b to the power of 3, do you recall this? This will be equal to a minus b, right? And then we'll have a square plus ab, right, plus b square. Now, do you recall this? Great. If you have this, then these expressions can be simplified further. If we substitute this into that expression, recalling that our a will now be equal to x, and then our b will now be equal to 5. It makes the expression easier. So if we insert that into the expression, we're going to have that expression to become x minus 5 on this side, right? And then we'll have our x squared plus x multiplied by 5, right? Plus 5 square, and all of these will be equal to 0. Great. Now, in the next step, we're going to simplify this zero product expression. If we simplify this, we are going to have that expression to now give us x minus 5, right? And this will be x squared plus 5x plus 5 squared is going to give us 25. And all of these will be equal to 0. Great. So with this zero product rule, we can isolate this to give us x minus 5 equal to 0 on one expression, while on the other side, x squared plus 5x plus 25 will be equal to 0. Now, from the left hand side, if we add 5 to both sides, our value of x will be equal to 5. And that gives us the first value of x. Now, from this expression, given the quadratic formula, we can find other values of x. Now, we're going to use a unique way of solving our quadratic formula. Now, given this formula, we can look at this expression as y equal to x squared plus 5x plus 25, right? If we have this expression, remember, we'll have this general expression as y equal to ax squared plus bx, that's the quadratic formula expression, plus c. And from this expression, our a is equal to 1, our b is equal to 5, and our c is equal to 25. Given this expression, we are going to look at using this formula. We'll look at the differentiation, the y dx of the first part of y equal to plus or minus the square root of b square minus 4ac, which is a partly quadratic formula. So if we insert that variation, those parameters into that expression, we'll have that expression to now give us the dy dx of our x square, right, plus 5s plus 25, and this will be equal to plus or minus the square root of 5 square minus 4 multiplied by 1 and multiplied by 25, which is c. Great. Now in the next step, we'll simplify this. If we differentiate this, we're going to have this to become 2x plus 5, right? And this will be equal to plus or minus the square root of 5 square is going to give us 25 minus 4 times 25 is going to give us 100, right? Good. So if we have that expression, we'll simplify for that. To simplify for that, we'll have this to be 2x plus 5 equal to plus or minus the square root of 25 minus 100 is going to give us a negative 75. Good. So how do we simplify? 75 is going to give us should be equal to 25 times 3, right? If we multiply 25 times 3, we're going to get a 75. So what we're going to do is to simplify that. So we're going to have 2x plus 5 to be equal to plus or minus the square root of 25 multiplied by 3, and that's going to be multiplied by negative 1, right? Good. So we are going to simplify this. This is going to give us a 2x plus 5, and that will be equal to plus or minus the square root of 25 on one side, right? The square root of 25 on one side, the square root of 25 on one side, multiplied by the square root of 3, and multiplied by the square root of negative 1. Now, square root of 25 is going to give us 5, so we'll have a plus or minus 5 multiplied by the square root of 3, and from our complex expression, square root of negative 1 is going to give us a j, and this is going to give us 2x plus 5 equal to that. So if we simplify this further, we're going to have 2x, right, to be equal to negative 5. If we subtract 5 from both sides, negative 5 plus or minus 5 root 3j, right? Good. So if we divide both sides by 2, dividing both sides by 2, we're simply going to get the value of x. 2 cancel out 2, and then the value of our x will be equal to negative 5, which is common, negative 5 plus or minus 5 root 3j divided by 2. Now, having gotten that, this is going to be the expression for the value of x. Now, recall that from the first exam, from the first answer, we got the value of our x to be equal to 5. That is s1. So we're going to have our s1 to be equal to 5. We'll have our s1 to be equal to 5. And then our s2 will be equal to negative 5 plus 5 root 3j divided by 2, and then our x3 will be equal to negative 5 minus 5 root 3j divided by 2. And these are the solution of x that satisfies that expression given to us up there. You see, very easy. Now, considering this unique quadratic formula we use in solving that quadratic expression and the solution we prefer to this question, I want you to review this question and then check if our solution is actually right. If you did enjoy watching this math solution, don't forget to give it a thumbs up, share it with friends and colleagues, and remember to subscribe to my channel for more simplified maths content. Thanks so much for watching, and bye bye for now.